and they will be differentially substituted. And the goal of part one, anyway, is to make what's called a chalcone. And this will occur through an aldol reaction. So your chalcone is going to look something like that. And depending on the R groups that were on the aldehyde and ketone that the starting material is going to be, it's going to give you a different chalcone. And because everybody's starting with something different, everybody's making their own unique chalcone, you're going to end up having, running into your own unique issues. All of those chalcones, because they are differentially substituted, are not going to behave the same. In terms of solubilities, in terms of your purification strategies, etc. And so everyone's going to run into their own unique issues that you will have to figure out a way to overcome. The other aspect of this is there are two different procedures. In addition to being assigned your aldehyde ketone pair, I'm also going to assign you one of two procedures. So one of which is just kind of the traditional solution phase reaction. All right, so this is the way you think of doing the reactions all the time. You just take your starting materials, you dissolve them in a solvent, you'll reflux it or heat it. I don't think it's reflux, but you'll heat it for a period of half an hour or so. Just a normal run-of-the-mill reaction. The other procedure is going to be a solid phase synthesis, so solvent-free. And so those are the two things I need to give you so that you can proceed with the project starting on Monday. All right. In terms of how you're going to get these, like I said a minute ago, these are not in the lab manual. So what you're going to need to do is go onto Canvas under the lab module. You will find there are 3 different files. There are 2 files for the solid phase. The one that's probably going to be most important to you is the supplementary material. There's the files for the solid phase is actually a research article published in the Journal of Chemical Education. You can go through and read the actual article if you like, but you'll certainly want to check out the supplementary material because that is where you're going to find exactly how they ran the reaction. And so if you get assigned the solid phase, that's how you're going to get your procedure. All right, so you would want to, over the weekend, look up that article, read the supplementary material, and then you can write your procedure based on the supplementary material, based on the way they did the actual experiment. Okay? If you get assigned the solution phase, there is also a file under the lab module for that. I think it's just called solution phase chalcone synthesis or something like that. That is literally just a procedure. So it would be fairly easy for you. You're just going to look up that file and then run the reaction as outlined in that procedure. Okay? Now, all of that said, we have, what do we have? All of next week and then the Monday? No, yeah. All of next week and then all of the following week because classes end on Wednesday. So that means you have 4 lab periods to do the project. Okay? The project, as I said, is a 2-step sequence, the first of which is the formation of the chalcone. And then in the second step, you are going to take the chalcone and further derivatize it. Okay? You have 4 lab periods to do that. It should be more than enough time. That said, I really don't care how you manage your time. you're all adults, you can manage your time better than I can. So if you want to come in, start on Monday and try to get it all knocked out next week in 2 lab periods, I'd be pushing it, but it's probably possible. You can do that, and then you don't have to come to lab the last week of classes. Or, if you prefer, you can kind of blow off the project, don't come to lab until the Wednesday of the last day of instruction, and try to get it all done in 1 day. I don't recommend that for the record. But it's really up to you. However you want to handle your time, you know your schedule better than I do. Do what's best for you. I don't really care how you do it as long as it's done by the Wednesday, the last day of instruction. Okay? Does anybody have questions on that? Okay, so at some point today, when you reach a lull in your activities, what I would like for you to do is come up to me. I am going to assign you the aldehyde ketone pair that you'll be working with. And then I thought for fun, instead of just assigning you a procedure, we would leave it to chance. So I'm going to have you roll the die. And let's just say, I don't know, even numbers get solution, odd get the solid. And we'll do it that way.
Can I use my own dice that I brought?
Hey, if they're your lucky dice, then go ahead. Okay, so yeah, at some point today, just come find me. Just bring something to write with, because I'll just write your aldehyde ketone pair on that sheet of paper that you bring with you, or your iPad or whatever. And then I'll have you roll the die, and then based on the number you get, we'll dictate the procedure for your child cone synthesis. Okay? Okay, then let's talk about what we're doing today.